Okay, so now we want to talk about a few algebraic methods of solving these pairs of linear equations. So basically we got these pairs of linear equations, and you need somebody to solve them, right? So you want to know, for example, you have 2x plus 2y plus 2y plus 3 is equal to 0, and for example x plus 5y, for example, minus 7 is equal to 0. You have this pair of linear equations and you want to solve them. So one way would be to basically draw the graph of these equations, and you would get, for example, two lines over here, and then you could say that, for example, this line is this point is the solution of basically this pair of equations, because this point actually satisfies both of these equations. But of course this is not very convenient, because all the time you'd have to basically draw the graph of both the lines, and then it's just well, I mean, not always is it the best thing to do. Okay, of course sometimes it's actually very I mean, sometimes sometimes this is the best thing that you could do, but most of the time really not. So now we need actually some way in order to find out what x and y is in these situations. And so one way that you can actually solve these problems is called the substitution method. Substitution method. Okay, so the substitution method is the method that I used in the previous video in order to solve a couple of those problems. For example, you have these two equations and you want to solve them. So you take for example this equation over here and write it as 2x, and it is 2x plus 2y plus 3 is equal to 0. So what you can do is that you can express x in terms of y, meaning that you write 2x is equal to negative 2y minus 3, and then x is equal to negative y minus 3 by 2. And so that is x in terms of y. And then you can substitute this 3 by 2 actually. And then you can substitute this value of x in the second equation over here, meaning that instead of x you can write negative y negative 3 by 2, for example, plus 5y minus 7 is equal to 0. And now in this equation you have only y, and so it's an equation in one variable. And then you can solve it. For example, you can write that negative y plus 5y is equal to 7 plus 3 half, and then 4y is equal to, I don't know, this is 3 half is 1.5, so that would be 8.5. So 8.5 would be 8.5 would be 17 halves. 17 halves. So then y would be equal to y would be equal to 17 halves divided by 4, which is equal to 17 halves times 1/4, which is equal to 17 eighths. So then your y is equal to 17 eighths. And now that you know what your y is, you can basically put your y, you can substitute your y in any of these equations and then get the value of x. So here, for example, you know that x is equal to negative y, so negative 17 eighths minus 3 halves. So it's equal to 8, for example, 8 negative 17 negative 12, so that's equal to negative 29/8. So that's the value of your x, that's the value of your y. That's basically all there is about the substitution method. So basically I have two equations over here. You find in any of those equations, wherever you find it convenient, you basically express one variable in terms of the other variable, and then you put that basically, then you get something like this. For example, x is equal to basically some expression in terms of the other variable, and then you have to take that variable and substitute it in your second equation, and then that way you will get some value for example y, and then now you know what basically the value of one of your variables, and then you can again take this value and put it in any of these equations, and then that way you will be able to calculate x as well. And that's basically all that you do here. So it's simple, and usually basically the kind of thing that you do when you have two equations. Now there is only one thing that sometimes happens, and that is let me see what I did over here. So, and we will have basically two examples for this. Sometimes in some examples you will get some statements with no variables, meaning that for example you would get, when you substitute, for example, when you substitute I think it's better to show you this through an example. And that's basically all that happens here. So now let's do a couple of examples, and there is this sometimes this kind of weird thing that happens, that all of your variables all of a sudden disappear. But we will see that in an example, so we don't need to worry about that. So let's say that you have for example two equations, like for example s minus 7t plus 42 is equal to 0, and then you have s minus 3t is equal to 6, for example. You have a pair of linear equations like that. And so now, since you want to use the method of substitution, you basically need to find one variable in terms of the other variable. So for example, you can take 2 over here and write it as, for example, you can find s in terms of t. So you would write s is equal to, for example, 3t plus 6. So that would be s in terms of t. And then you can take 1 and substitute s in 1, basically 3t plus 6. So instead of s, I can write 3t plus 6 minus 7t plus 42 is equal to 0. And 3t minus 70 is negative 40, is equal to negative 42 minus 6. So minus 40 is equal to negative 48, and divide by, you can simplify these negative signs and then divide by 2. You will get a 2 divided by 2, 24, divided by 2, 2, divided by 2, 12. So t is equal to 12. So now that you have the value of t, you can put it back in any of these equations, whichever one is more convenient, to get the value of s. So for example, I pick equation number 2, s minus 3t is equal to 6, and then t is equal to 12. So that means that s minus 3 times 12 is equal to 6. So s minus 36 is equal to 6. S is equal to 36 plus 6, which is equal to 42. S is equal to 42. So this is the value of s and t in this pair of equations. But sometimes something like this happens. For example, let's say that you have a pair of equations like this. For example, 2x plus 3y. 2x plus 3y is equal to 9, and 4x plus 6y is equal to 18. So if you take a look at this pair of equations, you can see that a1 to a2 over here is equal to 2 to 4. Okay, and b1 to b2 is equal to 3 to 6. So this is actually 1 to 2. This is also 1 to 2. And also c1 to c2 is equal to 9 to 18, which is equal to 1 to 2. Okay, so that means that a1 to a2 is equal to b1 to b2 is equal to c1 to c2, and so that means that you have a pair of coincident lines. Meaning that the lines are equivalent. Okay, that means that you're basically dealing with the same lines, meaning that if you take 2x plus 3y is equal to 9 and multiply it by a factor of 2, you will get 4x plus 6y is equal to 18, which is basically the same thing that you have over here. So what that means is that you have a pair of coincident lines, meaning that you have infinitely many solutions. Okay, so now let's try to solve this problem and see what happens if we use the method of substitution here. So you have 2x plus 3y is equal to 9, and you have 4x plus 6y is equal to 18, and this is your pair of equations. You want to use the method of substitution in order to solve the pair of equations. So what you will do, for example, I call this equation number 1 and number 2. I take number 1 and express, for example, x as x in terms of y, for example. So I write 2x is equal to negative 3y plus 9, and then x is equal to negative 3 half y plus 9 divided by 2, and that's the value of x here. That's the value of x here. So now I take 2 and substitute x in 2. So 4 times negative 3 half y plus 9 by 2 plus 6y is equal to 18. and then that is negative 6y plus 18 plus 6y is equal to 18, and you see these two will cancel out and you will get 18 is equal to 18, which is of course true. So what that means is that when you get a true over here, that means that this pair of equations has infinitely many solutions. And of course you know the rest of the story. That means that you have a pair of coincident lines, and the rest of the story, and so on and so forth. So and basically this kind of thing happens because both of these equations are actually the same equations, meaning that, again, if you basically, for example, take equation number 2 over here, and 4x plus 6y is equal to 18, divide all terms by 2, you will get 4x divided by 2 plus 6y divided by 2 is equal to 18 divided by 2. That would be 2x plus 3y is equal to 9. 2x plus 3y is equal to 9. So you're basically dealing with the exact same equations. So of course, if you take, for example, some value of x from this equation and put it, for example, in the same equation, you are going to basically your variables are going to cancel each other out because it's basically the exact same equation. That's basically why this happens. That's basically that. Or let's do another example here, and I hope that we will get to something that is not true and false. So let's see if we can get that. Okay, so and if you remember that situation that we have with the rails, then basically we had two equations that represented basically two rails that never actually crossed one another. The equations were x plus 2y minus 4 is equal to 0, and then 2x plus 4y minus 12 is equal to 0, and these were the equations. So, and again, if you take a look at the coefficients here, a1 to a2 is equal to 1 to 2, b1 to b2 is equal to 2 to 4, which is equal to 1 to 2, and c1 to c2 is equal to negative 4 to negative 12, which is equal to 1/3. So you see that a1 to a2 is equal to b1 to b2, which means that you have a pair of parallel lines. You have a pair of parallel lines, so no common solutions. Okay, you have no common solutions. Now, if you suppose you want to solve this equation using the substitution method, so the equations are x plus 2y minus 4 is equal to 0, and 2x plus 4y minus 12 is equal to 0. And let's say that I take equation number 1 and express x as x in terms of y, so negative 2y plus 4, and then I substitute this value in 2. So if you take this 2, so 2 times x, which is negative 2y, 2 times negative 2y plus 4 plus 4y, negative 12 is equal to 0. That's negative 4y plus 8 plus 4y minus 12 is equal to 0. And these two will cancel out, and you will have negative 4 is equal to 0, which is of course false. Okay, so that means that you are actually getting no values. Basically negative 4 is equal to 0 is false for all values of y, and that basically means that there are no common solutions, and that means that basically the two lines basically never meet. That's basically that's basically what happens here. So we have covered all the different cases that might happen, and so this was basically the substitution method. Now there is something else called the elimination method. There is something else called the elimination method, and basically what that is, that's basically a way of eliminating or basically removing one of the variables, and then you will be left with only one variable, and then you will be able to solve the equation. So for example, let's say that let's have we have an example over here. So the ratio of incomes of two persons is 9 to 7, for example. The ratio of incomes of two people is basically equal to 9 to 7. And the ratio of their expenses, the ratio of expenses of the same two people is 4 to 3. Okay? Now, if each of them manages to save 2,000 rupees per month, if each manages to save 2,000 rupees per month, you want to find their monthly incomes. Find their monthly incomes. So now let me first understand what the question is. So the question is that the ratio of incomes of two people is 9 to 7. Their expenditure is 4 to 3. And if each manages to save 2,000 per month, so that means that if basically find their monthly income. Okay, so let me see how we can solve this problem. Okay, so now in order to solve this question, this problem, of course you need basically two equations, two linear equations, and in order to form those two equations, you need to understand how basically the meaning of ratios. So when we say that the ratio of incomes of two people is 9:7, what that means is that, for example, let's say that you have two numbers, 2 and 4. Okay, so if you take the ratio of these two numbers, that would be 2:4, which is the same thing as 1:2. So then you can say that the ratio of these two numbers is 1:2. So here basically you can say that the ratio is equal to 1:2. You can write it as 1:2 as well, this way or the other way. It doesn't make any difference. Now, if you know the sum of those two numbers, let's say that, for example, you know that the sum of those two numbers is equal to 4 plus 2 is equal to 6, then you can find those two numbers. Otherwise all you know is just the ratio, right? And what that means is that you know that the sum of two numbers is equal to 6 and the ratio is 1:2. So how can you find those two numbers? If you take one of those numbers as x, then the other number is going to be 2x, because the ratio is basically 1:2, meaning that x to 2x is going to be equal to 1:2, right? So you can take this one as x, and then the other one becomes, of course, 2x. So what that means is that you can write x plus 2x is equal to 6. The ratio of this, basically those two numbers, x and 2x, if you add them together, you will get a 6, and that's basically their sum. That means that 3x is equal to 6 and x is equal to 6/3, which is equal to 2. So now that x is equal to 2, that means that 2x is equal to 2 times 2, which is equal to 4. So 2x is equal to 4. Okay, so basically this number over here was equal to 2 and the other number was equal to 4, and that's basically the numbers that we started with. And if I add these two numbers together, 2 plus 4, I'm getting a 6, which is basically the sum that I had over here. So that's basically how ratios work, right? So now we can use this concept here in solving this problem. So I know that basically the way basically expenses and income and expense works. So you know that your income minus the expense minus the expenses is going to be equal to your saving, meaning that your saving is going to be equal to how much income you have minus your expenses, right? So now if I take the ratio of incomes here of these two people, 9:7, so I have to basically use two variables here, x and y. And if the income of the first person is 9, if I use the variable x for the income over here, and use the variable y for the expense over here. Of course, right now this is just a vague idea in my mind. Let's see how it actually works out. Okay. So what that means is that basically the income of the first person, you can express it as 9x. Whatever basically the income, if I express the income of the first person as 9x, the income of the second person is going to be 7x. And if I use the variable y for the expenses, then if I express the expenses of the first person as 4y, then the expenses of the second person is going to be 3y relative to the first person. So then what I can do is that for the first person, I can write his income is basically 9x, his expenses are 4y, income minus the expense is equal to the saving, and each of them manages to save 2,000 rupees per month, so that's equal to 2,000. And also the second person, his income is 7x and his expenses are 3y. That's also equal to 2,000 because he also manages to basically manages to save 2,000 rupees, and that way you have two equations over here. Now you can actually solve these two equations, and this method of elimination is actually the same thing as the method of substitution, but it's a little bit more structured, you know. For example, what you can do here, you see that basically you want to find some way in order to eliminate one of your variables. So 9x minus 4y is equal to 2,000 and 7x minus 3y is equal to 2,000. So if I want to eliminate my y's over here, what I can do is that I can if I call this, for example, equation number 1 and equation number 2, what I can do is that I can multiply 1 by a factor of for example 3, multiply 1 by 3 and 2 by 4. So what that means is that if I multiply 1 by a factor of 3, I will have a basically negative 12y over here. And if I multiply basically 2 by a factor of 4, I'll have a negative 12y over here, and then I can cancel them out, meaning that I can meaning that I'll be able to, for example, subtract this equation from this equation, and then if I subtract it, then over here I would have basically negative 12y, and then I subtracted a negative 12y over here, which I would get over here, and then that would be negative 12y plus 12y. That would be equal to 0, and then that way my y's are going to be cancelled out. That's basically why I do this over here. So now if I do this over here, I'll get, so basically multiply 1 by a factor of 3, I'll get 27x minus 12y is equal to 3 times 2,000 is equal to 6,000, and multiply 2 by a factor of 4, I get 28x minus 12y is equal to 8,000, right? So now I have this, I have actually, these are actually the same equations. I have not changed anything in these equations, unless I have just multiplied them by a factor of 3 and a factor of 4, and you can multiply your equations by any factor, and since you're multiplying everything by the same factor, you're not changing the equation. And then now what I need to do, you see that I have negative 12y over here, negative 12y over here. So I So now I subtract, and this becomes, for example, 1, and this becomes 2, right? Now you can subtract 2 from 1. Subtract 2 from 1. The way that you can subtract is that you can take the algebraic opposite of each term in 2 and then add it to 1. Meaning that, for example, if you have two polynomials or two equations, A and B, if you want to subtract B from A, that would be A minus B, right? Now what you can do to do the same thing, you can take the algebraic opposite of B, which is negative B, and add it to A. So A plus negative B. And that would be A minus B, which is basically the same thing over here, right? So now in order to subtract 2 from 1, I'll take the algebraic opposite of 2, the algebraic opposite of 2, and add it back to 1. And that would be the same thing as subtracting 2 from 1. So now I'm going to do the same thing over here. So I take the algebraic opposite of 2, meaning negative, positive, negative, and then add these two terms together, these three terms together. So 27x minus 28x is negative x, and these two will cancel out as I wanted to, and that's basically what I wanted to do. And then this is equal to negative 2000. So negative x is equal to negative 2000, x is equal to 2000. Okay, and then I can pick any of these equations over here. I have the value of x over here. So for example, I can take this equation over here and write 9x minus 4y is equal to 2000. I know my x is equal to 2000. So 9 times 2000 minus 4y is equal to 2000. And that's 18,000 minus 4y is equal to 2000. And that is negative 4y is equal to 2000 minus 18,000. So negative 4y is equal to negative 16,000. And y is equal to 16,000 divided by 4 is equal to 4,000. So I know that x is equal to 2000, y is equal to 4000. 2000 and 4000. X is equal to 2000 and y is equal to 4000. So what we wanted to do is that we wanted to find their monthly incomes. So their monthly income is going to be simple to calculate now, because their monthly income was basically 9x and 7x. So 9x would be equal to 9 times 2000 is equal to 18,000, for example, rupees for the first person. And for the second person, it was basically 7x is equal to 7 times 2000, which is equal to 14,000 rupees. And that's basically how you would solve this kind of problem. So 14,000 and 18,000. So this is basically called the method of elimination. You pick something over here and you basically multiply your equations by some, usually one factor, basically one multiplication is enough, but here basically things were a little bit more complicated, so we had to multiply both of these equations by two different factors in order to get the same terms over here, so we could cancel them out. And then once they're cancelled out, you'll be left with only one variable, and then you be able to solve the two equations for that one variable. Find that variable, put it back in one of these equations, and you will get the other variable. And of course it could, I mean, the variable that you eliminate, it depends on which one is easier to eliminate. For example, if in this case I could have eliminated x as well, but since basically the coefficients of x are here larger than the coefficients of y, so I chose y because here I would have had to basically multiply, for example, this equation by a factor of 7 and this equation by a factor of 9, for example, in order to get them to get these two to, for example, 63x or something like that, which would have resulted in, for example, 7 times 2000, which is 14,000, and so on and so forth. The numbers would have gotten a lot bigger, so I chose to eliminate y. Otherwise you can eliminate x as well if that's easier. So and of course here sometimes you get those, basically what happened in the previous, in the substitution method. If you remember, we got basically a true statement, a false statement. The same thing might happen here as well, so you need to, and then that basically means the same thing, meaning that if you get a true statement, that means that you have infinitely many solutions. If you have a false statement, that means that the lines never meet and you have no common solution. So that's basically the same story. So now let's do a couple of examples here, and we will do a couple of examples here, and then we will get to another method of solving these equations, which is called the cross multiplication method, a little bit more advanced, but it's useful actually. So let's do a couple of examples with this, and then we will get to the cross multiplication method. Okay, so the next thing that we have here is another example. It's a little bit complicated, related to numbers and such, but the sum of a two-digit number, the sum of a two-digit number and the number obtained by reversing the digits, and the number obtained by reversing the digits, of the digits is 66. Okay, and if the digits of the number differ by 2, the digits of the number differ by 2. You want to find the number, and also you want to know how many such numbers are there. So basically you have the sum of a two-digit number And so you have a two-digit number, meaning that you have a number that has two digits over here, a and b, and so you have this number, and if you add it to if you add it to the number obtained by reversing the digits, meaning BA, for example, this sum is equal to 66. And if the digits of the number differ by 2, meaning that either a minus b is equal to 2, or basically b minus a is equal to 2, then you want to find this number, and you want to know how many such numbers are there. I think the answer might be 2, but we will see about that. So if you have, basically, if you take your original number as, basically your original number has basically these two digits, meaning that, let me rewrite this as, for example, let me take these as x and y. So basically I have these two numbers. I take this x and I take this as y, and then I have to reverse the digits over here, so that would be y and x. If I add these two together, I should get 66. And then the digits of the number differ by 2, meaning that y minus x is equal to 2, or basically x minus y is equal to 2. Both are possible. So you want to find this number and see how many such numbers are there. So since this is a number and not basically, since this is just some way of showing that this is a two-digit number, of course I cannot use it this way in an algebraic equation. So I have to write the value of the number based on these two variables. So the value of this number over here would be, so this is the ones place and this is the tens place. So that would be y times 10 plus x times 1, which is basically x. And this is the first number, I mean the original number. And if I add it to basically if I reverse the digits and add the value of that number to this number, I would get x times 10 plus y, and this is the ones place, so times 1, so I don't write it over here, and this is the tens place, so times 10. This is equal to 66. So now if this is 10y plus x plus 10x plus y is equal to 66, and then that's 11y plus 11x is equal to 66. And you can simplify this equation as divide everything by 11. I'll get y plus x is equal to 6. Divide everything by 11. Okay. So this is one. So then I'd have two situations. Either basically I get two pairs of equations, meaning that I get x plus y is equal to 6 and x minus y is equal to 2. This is one pair. And then, or I will get x plus y is equal to 6, which comes from here, and then x minus y is equal to, I'm sorry, y minus x is equal to 2. So this is the other pair of equations that I get. So now I need to solve these two equations in order to get the answer. So x plus y is equal to 6 and x minus y, y minus x. Okay. So if you want to use the method of elimination, it's easy to use the method of elimination because you see over here you have y and minus y. You can just simply add these two equations together, and then your y's will cancel out. So if you just simply add, these y's will cancel out. You'll get 2x is equal to 8, and x is equal to 8 divided by 2 is equal to 4. And then take any of these equations. For example, you can take 1. You can take 1, and then that becomes, for example, x plus y is equal to 6. So then you have your x is equal to 4 plus y is equal to 6. So y is equal to 2. So here your x is equal to 4 and y is equal to 2. Over here you need to rewrite this thing as x plus y is equal to 6, and then negative x plus y is equal to 2. And then if you add them together, and that would be basically simply the method of elimination, you get 2y is equal to 8. So y is equal to 8 divided by 2, which is equal to 4. And then you can take this as 1, for example, take this as 2. And then you have, for example, take 1 over here. X plus y is equal to 6, and then set y is equal to 4 here. And then your x is equal to 2 here. So either x is equal to 4, y is equal to 2, or x is equal to 2, y is equal to 4, right? So here what we said was that, so basically we get two cases, or we get two numbers basically. Either x is equal to 2 and y is equal to 4, or x is equal to 4 and y is equal to 2. In this case the number becomes yx, which is 42, and in this case the number becomes 24. And so now in this case, basically over here, what happens is that if you take this number, this original number, and reverse the digits, so 24, you get 66, and then the digits of the number of course differ by 2, because 4 minus 2 is equal to 2. So that's basically one valid answer. And here you have your original number is 24. If you reverse the digits, you get 42. So that's 66 again. And then of course the digits of the number, basically 4 minus 2 is equal to, if you take them in the other way around, in the reverse order, 4 minus 2 is equal to 2. So that could be a valid answer as well. So that's basically two possible answers that you could have over here. So that's the method of, that's basically, well, all of these are related to numbers, not that important over here, but important here is that basically you get these two equations and how you solve them by the method of elimination. That's basically all that matters here.